I think I'll go ahead and get started. So yeah, my name is Stephen Haberman. I'm going to be talking about a GWT MVP framework that I've been working on for a while. The basic goal is to hopefully make MVP not suck, because sometimes it usually does. So TESSELL has two goals. One was MVP automation, and the other that I put in the tagline is doing reactive data binding, which I've been doing the data binding thing for a while, but if you call it reactive, that's kind of the new cool thing to call it. So I'm going to really kind of quickly go through the MVP side of things, because I assume everybody here is familiar with you write the interfaces and the views and all of that jazz, and specifically focus on what TESSELL has differentiated. So brief purpose. The idea is that you could unit test your business logic, and ideally it's quickly in the browser. Here's a few TESSELL style tests where, like, let's say the name is required. You're going to click on a submit button and then be like, oh yes, my view errors, name errors is required. Same sort of thing you can do testing of server responses, like click the submit button and then say, server complained, and then assert that your presenter is showing the error in the. And the idea is these are all browser decoupled, DOM decoupled, so they run really quickly. And this is what we want to get to with the least amount of pain possible. So in that regard, historically what you've had to do for MVP is very manual, where you write your UI XML file, some sort of text box. You then have to do basically the same change. I mean, it's not the same change, but you go also change your interface to say, like, has text get foo, and then you do yet another change to your GWT some page impl, which is your little UI field text box, and finally at the bottom you get to do what you actually wanted to do, which is update your presenter to write to it or something like this. So what TESSELL does instead is you still have to change your UI XML file, but then you don't change your interface because this is generated for you. Notice that we use is text box instead of the previous has text. Because since this is done automatically, we have to look at the GWT text box and know which interface you want to return, and we can't really know, do you want has click handlers or has value or whatever. So we just have is text box, which has all of those. So you could do anything you want to it. Still an interface, so you can stub it out test time. Generated for you. The next step of generating the GWT view is again generated for you. This time it's using the is text box as well. You can see that technically the UI field is a GWT text box, which is really just a text box, but it's a subclass that also implements the interface. Is text box, right? I have to go back and, make all of the GWT widgets implement my special little interface. But you don't care about that because it's generated for you. And yeah, so you skip right directly to updating your presenter. And the result is, doing this really nice MVP cycle with no boilerplate. So now I'll show it. Yeah, okay, so here I am in Eclipse. I've got a UI XML file, so I'm going to make some sort of trivial little change to it. And as soon as I hit save, you kind of saw the console popped up. Oop, I didn't mean to make it big. But it automatically runs whenever I make a change and is running CodeGen at the bottom. I happen to be using Gradle to execute it, which is kind of nice. But as soon as I make the change, we parse the UI XML files that have changed, and I've automatically added my is text box foo, and also automatically added foo to my GWT implementation. And then if I take them back out, it will take it back out. So that is kind of like the first half of the TESSELL value proposition. There's technically one other view that it generates, which is, let's do something like, let's go over to our header presenter, which I get grief sometimes because I always extend basic presenter, but it's not technically required. It's just kind of nice. But there's a unit test for this that runs very quickly. It's testing things like, we're typing into the new to-do thing that if you hit key enter with nothing in there, it doesn't do anything, right? Because you haven't actually typed a name yet. But if you do type a name and you hit enter, then we do get one. What I wanted to show was that, you know, we have this new thing now. We added view.foo. You know, let's just do something silly to show that it works. So you can update your presenter and then right over here jump to your test. And I'm setting it in on bind, which means it should always be done. So we'll just, you know, assert it is silly. And if I look at my view.foo.getText, it should be right. So really simple stuff, but the idea is that I'm doing this all, you know, very quickly in a, you know, less painful sort of fashion. So I'll take that out. And that was pretty quick. This might be, this might go quickly. So, okay, so back to the slides. So that's kind of the first half of what Tessel does. The second part is the reactive data binding sort of stuff, which, no, I have not booked my flights yet. But, so two-way data binding between view and models with support for collections and derived values. Derived values is what, you know, I think lets me get away with claiming that it's reactive. And functional asterisks, which is that, okay, maybe technically I need to wait for lambdas to land to really claim it's functional, but, you know, it's close enough. And yeah, so the idea with data binding is that, you know, traditionally, like the swingish way to handle this is a lot of handler spaghetti code, where you're, you know, adding inner classes that listen to one thing, listen to the view and update the model, and, you know, listen to the model and update the view. And, you know, this gets ugly really quickly. I will have to admit that it gets a little bit better with lambdas because at least these aren't inner classes anymore. But this is still kind of a very, you know, low-level approach to doing things. And what Tessel wants to do, I'm going awfully quickly, but what Tessel tries to do is to think about this declaratively, where really in one line, ideally, you're saying, you know, you want to bind some aspect of your model to some aspect of your view, and then that's it. Like, somehow you just want these to be kept in sync. And it looks really, you know, simple for the, just a property to a text box, but you can also think about like how this would work with collections insofar as, let's say you have a model with some list of children, and you want to keep this list of children, you know, up to date with where you're, you know, with your UI. The idea is that if you provide Tessel with a list view factory, which just maps one DTO thing to one presenter, that all of the other stuff is boilerplate, right? If you have 10 of them, if you have 10 and then you have 11, or you have 10 and then you have 9, you know, that this should be able to listen to model changes and, you know, and update the view. It also is, the collections is kind of fancy. It will listen to the diffs of the model and actually watch for like move things. So if you move something from like slot 8 to slot 2, it actually won't create your widget. It'll kind of, you know, remove it from slot 8 in the panel, move it to 2, which I don't know how often that's entirely useful performance-wise, but it sounds cool. The binder, so I've got the, you can see in the first example there's this binder.bind, which ends up being this DSL sort of thing, which also has some nifty things for doing like conditional logic. I could probably just turn off my Wi-Fi because everything's local. There we go. That will solve the chat messages too. So conditional logic. So let's pretend we have this, some sort of editing flag, like editing yes or no. We can say, well, when that's true, you know, set some sort of CSS class on an element, right? Which is terribly, you do this all the time. And there's other variations on this DSL of adding and removing things from lists and that sort of thing. Yeah, so this data binding is kind of the other big thing that Tessel does. Yeah, there's some other examples about on user input. So, you know, whenever they do key down, specifically the key down I'm interested in is escape. The editing thing, it kind of knows about, we'll get to that later, but it's properties, so the DSL can do some nice things about that, about, you know, sending back to false. And I'll show some more examples of this when we look at more of the to-do application. So the large caveat to all of this data binding stuff is that, unfortunately, we need properties. So, You know, given a classic DTO that you might get over the wire, right, like child DTO name and salary, unfortunately you can't really like bind c.name, right? Like name is a field, name is not going, you don't get change events for a field, right? When DTO.name changes. And so what Tessel does, and that I think basically everything before Angular did, you know, like if you look at some of the earlier JS-rich frameworks, is make models and properties of everything. So instead of your child DTO, you have a child model, which instead of primitive, you know, strings for your names and your fields and all of that, so you basically promote them to properties. The property, you know, can have listeners, it can have its, you know, last value, known value, so fire change events, can have validation rules, which is really common, and that sort of thing. So it basically makes it a first-class notion of, you know, this is something that can change. So yes, so now that name is a property, you can see that you can either do the very kind of manual thing of make a new child model, go to your name and like tell me when the name changes, and then you know, do something very explicit. Or you can start using the binding DSL, which you know, will generically take anything that has, you know, property change methods on it and be able to do other things with it. So that's the large caveat. The thing with models is that it sounds like a whole nother realm of boilerplate, right? Like, well, I've got my DTOs, I'd just like to keep DTOs. The answer to all boilerplate is code generation. And I technically have a separate project that I won't focus too much on that was not originally written for this. It's called Detonator, and the original purpose was to map DTOs to domain objects, which I've always really disliked doing. But you know, when you have sending stuff over the wire, you pretty much always do it. So with Detonator, the idea is that you write a YAML file, which is your, you know, you want some sort of child DTO. You specify the domain object and the list of properties you want. It'll use reflection to be like, oh, well, the ID is a long, the name is a string, so you don't have to, you know, retype out what the types are. You can technically do star if you want all of your properties, but that's not as common. So basically, inside a Detonator, I added one little, ideally, I like to keep projects separate, right, and not kind of bleed everything into one big ball of mess, but it was awfully handy to just teach Detonator about Tessel to say, like, by the way, also generate Tessel models. And the output is very nice. Now, you know, you have the YAML file. Whenever you change the YAML file, you get brand new DTOs, and you get child models that have all of those, all of your fields that were in the DTO also promoted to properties. So now you can do all of the bindings and all of that other sort of jazz. Right now, the child DTOs that I use GWT.RPC to go over the wire, because that's what I started out using. But it's all code generation, so there's really no reason you could also, you know, go change it to output JAX, RS, whatever cool stuff, which actually I'd like to do, but just haven't got around to it. So that's my excuse of, like, it's not that bad to get models. And yeah, so the reactive part is that it will track, not only you can look at name and the string property and kind of imagine in your head how that works. It'll also do tracking changes, you know, through derived properties, which is, I just made up this example of, let's say you have a name and you have some sort of max that defaults to 10, and you want like the first, you know, 10 characters of the name. You can write you're going to call it the short name. So you have a short name property that's some derived property, and inside the inner class you provide what this value is. And basically what happens is that the property will evaluate the get derived value, and while that's evaluating, it will watch every other property you touch, and then start watching those for when they change. So you call name.get, it's like, oh, well, you touched name, I'm now going to watch for when name changes. And no, you touched max, so I'm going to watch for when max changes. And so now, anytime that name or max changes, it will you know, reevaluate your derived property and fire change events, or update the UI, or what have you. And this actually works fairly well. I don't know if it's surprising or maybe a little surprising, because it seems like one of those things that could very easily go wrong, like all of a sudden you have a cycle and changing and changing and changing and that sort of thing, but it hasn't happened yet. And there's a few short circuits in there to keep that from happening. You know, you can tell if you're evaluating, but anyway, it works surprisingly well. And you know, just ends up using it all the time sort of thing. Like, you know, you have a list, that has a size, and you want to do things for when the list size changes. So, your list size returns a derived property that's just the size of the list, and it's a property, so you can do very easy conditional logic on it. And the cool thing is that soon this gets even better because we get lambdas and can do something like, little lambda thingy where you start inlining the derived property sort of stuff. I have a branch that kind of sort of does this, but haven't published anything yet. So, but that'll be pretty cool. I want to do that soon. So yeah, so that's the reactive stuff. What else do we? Yeah, so I've got a demo. I don't really remember what I was going to show for the reactive stuff, but I can. I have my backup. What I'll show is so here's the canonical little. I think I have the browser up to do MVC sort of thing, right? I did have one thing that we can do later, but where you check things and you can clear the completed and all of that. What's kind of interesting, I did this a little bit differently than most to-do applications insofar as I really broke it out into small little components, which is perhaps not necessary for this small app, but I think really shows how GWT handles that really well, right? You can do lots of small little things, and it makes a lot of sense when you have a large application. So I split them all up into like, here's the header, or here's the header and the footer. But to look at some of the really cool reactive stuff is to look at the to-do one, which is specifically where we show, this is one to-do. We now have 5 to-dos, and this is the one of them it's going to be an LI tag with a checkbox, and the name is in here somewhere. Here's the name while you're editing it. Oh, and then the label is the name when you're not editing it. But then the code for this looks like this. So here's our to-do presenter, and the idea is we'll have one of these to-do presenters for every to-do on our screen. But this is just an awfully nice demo of what the binding DSL and a lot of this abstraction, or the reactive stuff will do for you. The to-do that we take, it is a model. It's usually, I have to-do DTO and to-do model, but there's no server here, so it is just a model. It's a to-do model that uses the Boolean properties for done and name. But yeah, I can read through some of these, by the name to the text of the label. Whenever the to-do name is null. Oh, yeah, this is like if you go take the name and delete it and hit enter, that will change the name to null, which is basically like deleting it. So we say like when you delete the name, clear the name, remove the to-do from all of our to-dos. Bind a checkbox. This is pretty simple. Here's another example. I put this in the slides of conditionally setting a style on something based on the to-do. Yeah, so I don't think I'll read all of those. Here's a non-click. When you click remove this to-do from the lists. The DSL has a lot of built-in stuff about models and lists because you do that a lot. But oh, I do have an example of using the reactive stuff. The more sort of reactive thing is here's just a small little app state which I pass around to hold all of the list of to-dos. List property is the smarter version of list that knows about changes, and it fires value added, value removed, and good things like that. It also has some nice methods on it, like you might want to have your to-dos, but then filter down the ones that are only done. This is also smart enough insofar as like this filter, we look at all 5, but if any of the 5, we're again looking at each to-do done. So if that flips, if all 5 were done, but the 4th one is no longer true, then it kind of reevaluates the filter on what needs to be changed. And number left is more of a traditional, dry value of get my to-dos. .get is going to register that, by the way, I need to change whenever all to-dos change, and I need to change whenever done to-dos change, and just subtract those two. But yeah, so that's the demo of the reactive stuff. I'm doing extremely good on time. So I do have a few more slides. I guess I could have shown more, but so those are the 2 main things Tessel does. It does a few other things that I don't think it's a necessarily huge deal, but it's nice. It's got a pretty minimal places implementation, which is not at all fancy. It's just you put a little annotation of gen place of, the idea is that you'd have a presenter and you know, anytime you hit, you know, hashtag my place, it'll end up calling your static method to be like, okay, presenter, you're in charge now. Here's the request that, you know, might have some parameters on it, and you can pass in, you know, let's say your top level presenter or something like this, and kind of do whatever you want in here. It's very not magical, which is kind of what I like. It also has some command pattern code generation, so it's basically a forkish of GWT dispatch, you know, which is pretty standard these days, with the idea that we should do some code generation around it, making it not suck. So this save client spec, the spec is, it means it's a specification. It's not like your code is going to use the spec class directly, but it gives a specification to the annotation processor, which is gen dispatch, to then go generate some code. So this will generate your save client action and your save client result. I use silly little lambda syntax here so it would fit on the screen. But, you know, it's not rocket science, but it sure beats hand coding those actions and results. What does come out of the box to handle some of the UI binder to you know, look at a UI binder and automatically generate the interface in the view is interfaces and stubs for basically any widget I've used over the last 3 or 4 years, which is, call it 80–90% of them. I didn't go through and like write them all because that would have sucked on day one, but you know, you write, you know, as you need them. So if you look at TextBox, I've got an interface for TextBox and a stub implementation of TextBox, which tries to do, you know, basically what a TextBox would do, right? And I think these are awesome insofar as they're not mocks. Like, I think sometimes mocking is great. It's kind of like how often you use it. Like, if you're going to use something like once or twice, then yeah, the stub is not worth it and mock it out. But like, you know, how many times are you going to test a stupid text box in your application, right? I think like that's the time where it crosses the threshold of you might as well write a stub that, you know, I don't have to, if you remember the test, I didn't have to do code of like when text box get text, do, you know, return the value or whatever. So I think that the stubs make a lot of sense. And I didn't put the full list here, but basically most of the widgets I have interfaces for. Insane stub implementations. And yeah, I mean, so kind of since I have an awful lot of time, I'll talk a little bit about the stubs for the widgets. They do try and do like a best practice or best effort sort of thing with emulating the DOM, right? I mean, your unit tests are not going to do crazy things about was the pixel blue at this offset or, you know, this sort of thing. So they don't try to, you know, do any rendering logic whatsoever. They do technically know their parent because there for a while, for some reason I wanted to go through the stubs and find elements by ID. I think it was because I was doing stuff with cells and that was important. It's kind of a pain in the ass, so I don't do that as much anymore. But they technically know, you know, the hierarchy of parents and all that. I have all sorts of time, so you're going to get to see one. So, like stub header view, this is what Tessel generates for the, when we're going to test the header presenter in a unit test, the idea is that we want something that implements our is header view, but is not an actual browser. So it just finds everything that you've got in your UI.XML file and says, well, I'll look up the stub version of that. There's a property file that drives this, and you can add your own for like your own custom widgets. So if you have, you know, whatever calendar awesome widget, you can say, well, you know, if you see, you know, my company : calendar in your UI.XML file, that means use this interface and this stub, you know, so you can provide your own widgets here. And then all of this is generated about, you know, just make the new stubs. And where's the new to do? Yeah, here's the getters. They don't start with get. It threw me off, but there's the getter. And the stub text box is really pretty simple too. It's, oh yeah, stub text box base and all of that. But anyway, and yeah, when are you going to test direction in your presenter? So I didn't implement that stuff. I mean, if you were going to test direction, you can go implement it, I guess. But yeah, so that's the stub views. And Yeah, I'm to the benefits already. This is crazy. But, so the Tessel overview of benefits, it's actually been around a while. It's a mature, stable code base. I've been working on it for about 4 years, 6,000 some commits, 360 some releases, still around. All of the, and actually really stable. It's surprising how little, I push out a release once or twice a month as like, oh yeah, I need that widget or something like that, but not, the core seems really stable. All of the core functionality, like the data binding I've shown, it's all just Java code. And it's one of those things where, you look at something like, Angular and all of the magic it does and the templates, which is great, but part of doing this, like in Tessel, you'll do the binding directly in your presenter. An offshoot of that is like it's really easy to unit test because you really are, exercising the entire basic stack modulo, the little view elements of, all of the reactive logic, all of the on-change logic, all of that is happening just as much in your unit test as it will in the browser, but very quickly. And Java, so you can debug it and that sort of thing. So yeah, I think that's nice. The other thing about Tessel is that it very much started out life as a pragmatic, make my life easier sort of framework. And so far as like when I look at other reactive frameworks, they're more pure and academic insofar as they start with kind of the base notion is, actually some of them are kind of cool and they do these event stream sort of notions that Tessel doesn't do. But you'll just have something that can change and like a property. Let's say just say they start with a property and then it can change and that's it. Well, Tessel's properties they all have validation rules because you almost always want validation rules for your properties, and they also have this notion of touched, which seems not important, but it's really important in forms. Like if you have 10 fields on your form, you don't want to immediately show validation errors for all of them, right? So your properties are going to kind of keep track of what fields the user has touched, basically. And with the binding DSL, it'll automatically like on blur out of even if they haven't changed a field, on blur out, it'll say like, well, you touched that, so go ahead and show the validation. So validation rules won't actually kick in until something is touched, which is, yeah, just niceties that make it a little less of a pure reactive framework, but I think actually make your life easier at the end of the day. Yeah, all properties have validation rules, all properties have touched. So Tessel does have some weaknesses. It has a small community. I'll say small. There's no bootstrap archetype sort of thing to get started. Like I try and screw around with this every once in a while, but it's just not something I'm interested in. Or, I mean, I guess that must be it because I haven't done it. Which means day one setup is going to suck, right? Like setting this up on day one, I just don't have any pretenses that this is going to be nice. I can show a little bit about how the Eclipse setup works because it's actually pretty sexy and you could use it for your own things that are not Tessel. But day one, this setup's going to suck. The promise is that after that, it's going to be really fun, right? You get a lot of stuff after that that's nice. Tessel also doesn't take kind of this Rails battery included approach. I make no pretenses that this is like Meteor and does everything that you would possibly want in Run framework. It's more of, like if you remember Java web frameworks from the late 90s, early 2000s, it was more like, well, here's a framework, but like you got to go hook up your own database and you got to go hook up your own web front end and all of these other sort of things, such that it was much more of an exercise to the reader about how to fit it into a full stack. For whatever reason, that's kind of a style I like more, in terms of giving you the freedom of, I don't care what your server is, or you could write your own models and your own DTOs, or change detonator to generate whatever you want. But it means it's not as sexy as something else. And a lot of the stuff is optional. It has the GWT dispatch RPC stuff that I said, completely optional. I don't care if you use it. Same thing, the pre-activities in places, not required. And so as far as like using this on your project, if you have UI XML files, like you could start using this. And well, then you're doing the MVP thing if you're into that. Actually, even if you're not, you could start doing this as an easy way to do that. Yeah, I guess that's it. What was the code I was going to show since I have so much time? Oh yeah, I was going to show you how the Eclipse code generation stuff works because that is kind of cool. So I used Eclipse for a long time before I figured this out, but it turns out I'm going to go into the project properties. This is how the file on save stuff works. Like if I go change header.xml and put this in, and it runs down in the console. Like typically this is the sort of stuff that historical is like, holy crap, I'm going to have to write an Eclipse plugin. I don't, that would really suck. So I'm not going to do that. But what you can do is if you go into the project properties, they have this notion of builders, which you typically see the Java builder and Scala builder sometimes or whatever is in here. You can do this little new thing and make it and have it call a program, which is what I did. And the program I had called is if you use Gradle, Gradle has a little Gradle W thing, which is like a wrapper script. I used to just call Java, like the system Java command, and then down on the arguments do pass in the class path -cp and then lib/jar/star or whatever. But Gradle does all of the class path management for you, and if you do the little daemon thing, it actually runs acceptably fast. It's a little bit slower than when I was calling Java directly to run down there in the bottom. I mean, the runtime is the same, but the lag of starting up Gradle is just slightly less, but it's actually really quick. But the really cool thing is under build options, you can tell it to run during cleans, autos, and all of that. And you can specify, this is the cool thing, you can specify what resources it should pay attention to. Like, I don't want to run this every time I change any Java file in my project. So you can go in and tell it to only run when stuff in the views or the resources changes. Right? So this is you're changing other things that you're not constantly running this thing in the background. And so that's really cool. And then the other cool thing is you can also hook up the refresh such that if you're writing output to you're going to write output to the build gen Java source directory, you can tell it to right after it's done running, go look for changes in this file, right? So it should immediately, you don't have to wait for, the native polling is actually pretty quick these days, but you don't have to wait for Eclipse to wake up and realize you had changes. So yeah, other than that, it's just calling this Gradle Tessel thing, which is, I mean, it's just any other build thing where, how does that work? Am I in the right file? Oh, no, I wasn't. Yeah, so here's in Gradle how you do the task Tessel thing, which lots of times, so I'm tangenting off on crazy little topics, but here's your, how in Gradle you would say, here's a task Tessel, set up the class path of getting the jars, and here's your main class and args, and you're off to the races. You tell it your views package, resources, etc. And I think I'll call that good.